Hello guys, in this video we'll have a review of the topics we have discussed during the finals. So these are the topics: applications of Newton's laws of motion, work, energy, and power, momentum and impulse, and law of conservation of momentum. Under applications of Newton's laws of motion, we discuss friction, tension, inclined plane, pulleys, or Atwood machine, and then work, energy, power, and then impulse and momentum and conservation of momentum. Sige. We'll have it a little bit informal so that we can discuss it freely. Okay, so una yung friction. So, remember na yung friction acts opposite the direction of the object's motion. It resists the motion of the object. Pinipigilan niya yung pag-move ng object. So, nakadepende sa type of surface na may contact. So, pag rough yung surface, obviously, greater yung frictional force. Okay, so the general equation for friction is F multiplied by mu, or the coefficient of friction multiplied by the normal force. Pero depende yon sa type of surface. Kung flat yung surface, you know that the normal force is equal to the weight. So, that will be equal to mg. So, this will be your equation if flat yung surface. Pero kapag inclined plane, which you already know how to draw the free body diagram, and you know that normal force here is equal to the y component. I mean the y component, but it's actually the x component of the weight. So that will be mg cosine of theta. So dun siya equal. So kapag inclined plane, ito naman yung equation ng friction. So there are times that you will be applying this also sa pulleys or sa inclined plane, of course. Okay? And diniscuss din natin yung tension, at alam nyo na yung tension ay sa strings, okay? So, transmitted through strings if an object is being pulled by a string or being hanged using string. So, ito yung steps na sinunod natin so that we can have the step-by-step, way of solving tension problem. But, of course, kapag mag-exam na kayo, mabilis lang. I mean, you want to save time. So, you just have to proceed to step 4 and 5. Okay? So, step 4, add all the x component and then add all the y component. And, of course, do some necessary mathematics to solve the equation or simplify your equation. So, I have here some examples. So, naglagay ako ng example wherein 1 is different angle, yung isa naman same angle, and then what if yung isa may angle, yung isa wala. So, kapag different yung angle, so sabi ko nga, proceed to step 4 and 5. Summation of forces along the x. So, ito yon yung b sub x and then yung a sub x. So, knowing that a sub x is on the opposite side, so that will be negative. So, that theta, and then we have here the variance of theta, for theta, so that is b sub x, equal to 0 because we do not have any more x components. So, simplify this one, you will have this equation. Of course, you have no value for a, so dyan muna yan. And then, the forces along the y-axis, so summation of forces along the y. So, all the y components will be here, your b sub y, a sub y, and the weight, right? So, yung weight, negative. So, transpose na natin siya. So, para positive. So, we'll just have here a sine of theta plus b sine of var theta because they are both towards north. So, positive equal to mg. So, eto na yung equation mo for the forces along the y-axis. So, if you are asked to find the value of tension, of course, substitute mo muna ito dito. Okay, substitute mo yung value nito dito so that you will have a. So, the value of a. And now, you can work with the equation kasi isa na lang yung variable. Okay? So let's just leave it there. So if you want to try, you may have your own example or try yung guided practice problem or self-paced activity. What if same naman yung angle? Kapag same yung angle, the idea is same din yung value nung tension. Okay, equal angle, like this is 5 degrees and the other one is 5 degrees. So we'll have here a cosine of 5 degrees and cosine of 5 degrees. So that will just be equal to 1. So therefore, A is equal to B. So equal din yung tension. And then, for you to solve that, you can have, for the force along the y-axis, so this is your equation. But because they are equal, you can proceed to A sine of theta and substitute this one with A. So that will be plus A sine of theta equal to mg. So you have here A sine of theta and then A sine of theta. So you can simplify that. Okay, so you have here A plus E, okay, the value of that, and then proceed to the substitution, and then isa na naman yung value na kailangan mo, so equal naman yan. Next, paano naman kapag yung isa may angle, yung isa walang angle? So, let's just move it here, this one here. Okay. So, dahil yung isa is wala namang value, it's on the x-axis. So, pwede mo na ilagay dito na negative a plus b cosine of theta equal to 0. So, yung a na yun, so, we'll move it on the other side of the equation. That will be a equal to b cosine of theta. And you see that, okay, or you can have here, divide both sides by cosine theta or whichever. Okay, so here you can see that the only components on the y are the following. So let's add this one through. Okay, so this one is b sub y and this is the weight of the object, so that is mg. So you do not have the y component for a. Okay, so ito na lang maging equation mo. One is positive and the other one is negative, so we'll just simplify this. Okay, so you may have here b is equal to mg sine of theta, and now you have the value. You can have the value for b. Obviously, always naman given yung mass and you know the acceleration due to gravity. Okay, so sa inclined plane naman, we already discussed how to draw the free body diagram of this. And here, you know that normal force is equal to mg cosine of theta. So they're equal and opposite in direction. So they will be equal to 0. Okay, and here, if there is no friction or frictionless yung surface, the only force acting is mg sine of theta. So you will just have here acceleration is equal to mg sine theta over mass. And knowing that there is mass in the numerator and denominator, so you can have this equation. A is equal to g sine of theta. Because remember that in an inclined plane, the acceleration is not dependent on the mass, but it is dependent on the angle of inclination. Okay? But then, if there is friction, so this illustration is has friction, so we'll have here mg sine theta minus friction because they are acting opposite each other. So, and knowing that friction in inclined plane is mu mg cosine theta. So this will be your equation. And again, we have here the common mass in numerator and denominator. So you'll have here this one. A is equal to g multiplied by the quantity of sine theta minus mu cosine of theta. For other variables required, just use kinematic equation. In solving problems involving inclined plane, you may be asked to find the time it takes to reach the bottom, its velocity at the end of the inclined plane, or the length of the inclined plane. So these are the variables that you may be asked or required to solve. So just use the kinematic equations. Okay. We also discuss pulleys, right? So, yung mga pulleys ay simple machine. Okay, so we have here one vertical. Okay, so I have written the condition. So, what if M2 is much greater than M1? So, here. M2 is much greater than M1. So, kapag ka ganun, so it will be moving towards M2. Right? So, this will be your equation. Acceleration is M2G minus M1G over M1 plus M2. And then, you have the equation for tension. Although dalawa to, you can just have 1. Okay? Anyway, it will give you the same answer. So, ayan lang din siya. But then, if M1 is much greater than M2, of course, it will be moving this way naman para sa second condition. So, kapag si M1 naman yung much greater, so we'll have here M1G minus M2G over M1 plus M2. So, you can see that there will be changes in the equation for tension. And also this one changed. Okay? So, yeah. So, you have to know which is much greater or the direction, saang direction mag-move yung pulley. Okay, pag horizontal naman, so you can see na may surface dito. So, sa table and then nakahang yung object. Most probably, it would be moving towards M2 because M2 is much greater than M1. So, kapag walang friction, dito, so may normal force and then my weight, M1G, which is equal and opposite in direction. So, mag-cancel out na rin yun. So, yung only force na nag-act dito sa object is M2G. Right? So, yun na lang yung force. So, the summation of forces over mass. So, force is M2G all over M1 plus M2. And then, this is your equation for tension. However, if there is friction, okay, kapag may frictional force, it will be moving this way. So, Fk is towards that way and M2G is towards this way. So, we'll just have here M2G minus friction. So, this is a flat surface. So, the equation for friction is mu times mg all over M1 plus M2 so that you can have the acceleration of the pulley. And for tension, because it involves now friction, you can see na yun pa rin naman yung value ng, equation for tension using yung M2, but then sa T, tension using M1, so mag-iiba na yung equation. So, ito dapat may 1. Okay? Okay, for inclined plane, and say for example, this is frictionless, and then we set another two conditions ulit. So, M2 is much greater than M1, and then M1 is much greater than M2. So, nakadepende siya. I added these two conditions so that you may remember that the equations is not consistent. Hindi naman, ito lang lagi yung magiging equation. Okay? So, there are times now, what if ito yung greater and then ito? Okay, you may compare. And of course, kung frictionless siya or may friction, nakadepende. So, yung equations natin is not, depends on the problem or it depends on the conditions. Okay? Given on the problem. So, ayan. For tension, ganun pa rin naman. Isa lang yung pipiliin. Okay? So, pwede naman isa lang dito. So, same pa rin naman yung ibibigay. Yung magiging answer. Okay? Also, pwede rin naman kayo mag-derive kapag sanay na kayo mag-derive, which is kasi nga hindi naman consistent yan. Lagi lang naman siyang nanggagaling sa equation ng second law of motion, which is acceleration is equal to the summation of forces over mass. So as you can see, everything is derived from this equation. Again, because this is applications of Newton's laws of motion. Okay? So, ayun siya. And we also have lesson 8, which is work, energy, and power. So, here, knowing that work is the measure of energy transfer, okay, as you move the object caused by the force. So, the equation is work is equal to force times displacement multiplied by the cosine of theta. So, work is in joules, force is in Newton, and displacement is in meter. Okay? And we also know that work can be positive, negative, or zero. So, positive, negative, or zero. Kapag parehas ang direction ng force at ng displacement, halimbawa, tinulak mo yung object, so yung pagtulak mo, dun din napunta yung object kung saan mo siya tinulak, then positive yung work. Negative kapag naman opposite yung, kapag opposite yung naging reaction, I mean yung displacement. Yeah. Okay. And if the force and the displacement is perpendicular to each other, like this example, then work is zero. Okay, so in terms of angle, kapag acute yung angle or less than 90, positive yung work done. Pag more than 90 or obtuse angle, negative yung work done. Pag equal to 90, zero naman yung work done. And then, we have work energy theorem. So, it says that the net work done on the object is equal to the change in kinetic energy. So, work done is the transfer of energy, right? So, the change in that kinetic energy is equal to the work done. So, we have here delta KE is equal to work. Okay. So, knowing that kinetic energy is equal to mv squared all over 2. So, this is kinetic energy. We can have this. So, this is change in kinetic energy, meaning the final kinetic energy minus the initial kinetic energy. So, we can just substitute here. So, mv f squared over 2 minus mvi squared all over 2 is equal to work. And I have shown you the derivation of this, right? In solving problems, you can also use this one, delta v squared over 2 equal to work. So, if ito yung given, then work then. Ayan, you can work with this. Or you can have this one. Delta means the change in kinetic energy. So, there are times that an object is at rest. So, initially at rest or end up at rest or end up stopping. Okay, so you can use these equations. Okay, and we also discussed power. So power is the rate by which energy is transferred per unit time, or the measure of how much work is done per unit time. Okay, so for example, you're working, you're consuming 100 joule every 5 minutes. So you're talking about power. So power is measured in watts or joule second, joule per second. And then this is the equation. Power is equal to work over time. You can also have here the equation for work is force times displacement, right? So FD over time. And knowing that distance over time is velocity, you can have here power is equal to force times velocity. Ayan yung mga variables. Okay, next, lesson 9. So, in lesson 9, we discuss impulse and momentum or momentum and impulse. So, sabi natin, momentum is the measure of how difficult it would be to stop a moving object. Gaano kahirap pigilan yung object na gumagalaw or gaano kahirap pagalawin yung object na nakastop. Okay, so momentum is the product of mass and velocity. So there is direct relationship, which means the greater the mass, the greater the momentum, therefore the more difficult it would be to stop the object. Same thing with velocity. The greater the velocity, or we can say that the faster the object is moving, the greater the momentum. Therefore, the more difficult it would be to stop the object. Okay? And the change in momentum can be caused by a certain force. So this change in momentum is what we call impulse. So impulse is the measure of the change in momentum. Again, it can be obtained through the product of force and time. So J is the symbol for impulse. So impulse is equal to force times time, or you can also have here M delta V because it's the change in momentum. Okay? And because these two are related to each other, so momentum impulse theorem says that the change in momentum of an object is equal to impulse. So J is equal to delta P, or change in momentum, wherein we can substitute the equation for impulse, Ft, and then for the change in momentum, we'll have here M delta V. So with this equation, you can find the value of the force, you can find the value of the change in velocity or the mass. Okay, and here are the variables and the standard unit. Okay, and the last topic is the conservation of momentum. So according to the law of conservation of momentum, in a closed system, the momentum before an event is the same as the momentum after due to its constant conservation. And this event, in terms of momentum, is what we call the collision. So we can also say that the momentum before the collision is equal to the momentum after the collision. So mathematically written as P is equal to P prime, wherein P is the sum of the initial momenta of the objects, and then P prime is the sum of the final momenta of all the objects. So we also have to know what are the types of collision so that you will know what is the equation that you are going to use. Okay, so here are the types of collision. Basically, it's just two: elastic and inelastic collision. Under inelastic collision, we have perfect and imperfect. So in all types of collision, momentum is conserved. Okay, however, kinetic energy is sometimes conserved or not. So for elastic collision, so kinetic energy is conserved. While for inelastic collision, kinetic energy is not conserved, but momentum is also conserved. What happens to the kinetic energy? It can be transferred to other objects. Okay? It can be released on the surrounding. So, lastly, we have perfectly inelastic collision, wherein kinetic energy is also not conserved, but then this colliding object stick together after the collision. Okay, so for elastic and inelastic collision, these two types of collision, right after the collision, they will be separating or be moving away from each other. They will not be colliding, attaching or sticking together, unlike perfectly inelastic collision. So, kapag after the collision, naghiwalay sila, it's either elastic or inelastic collision. But then, if they stick together, nag-move sila together, this is perfectly inelastic collision. Why do you need to know that? Because we have these equations. Okay? So, kailangan ma-identify mo yung type of collision so that you can select which is the best equation to be used. So, again, if they move separately after the collision, it is either elastic or inelastic collision. Anyway, parehas lang naman yung equation. But then, if they move together as one, they stick together after the collision, then the type of collision is perfectly inelastic collision, and then you can have this equation. Okay? So, ayun siya. Okay? So, those are the topics. I'll be sending this PDF so that you can also have the summary of the equations that you can use. And now try solving problems involving this topic. So you may try to solve the guided practice problem again, or try to search some problems on the internet and solve it on your own. Okay, if you have any question, you can message me through MS Teams. Also, I'll try to make some video again on problem solving, mga one way na mag-solve yung mga ganun. And we'll have a review during our meeting. Okay? So, next meeting we'll have a review quiz. Okay? So, thank you for watching. Galingan sa exam.